Hello everyone, I am Neeraj, part of Kepro open source platform, working as a cloud infrastructure lead. Today we are going to discuss about some other process in DynamoDB, and these are data type, throughput capacity and auto scaling. So in my previous video, I have already discussed about what is DynamoDB, what is DynamoDB table, what are the core component of DynamoDB table, what are indexes, how to create a DynamoDB table using AWS console. And now we are going to discuss these other things. Let's start. So we have data type in DynamoDB, read write unit and throughput capacity in DynamoDB. That is important one, we'll discuss. And DynamoDB peak traffic property. What is that actually? We'll discuss. So DynamoDB data type. So what is data type? Do you think it is needed to discuss? No, because most of people, either you belong to infrastructure background or development background, you know data type. What data you are going to store, you have to define the type of that. It's a string, it's a number, it's a name, it's an image, or it's a minus number, plus number, all things. So what data you're going to store, in that column you have to define data type. So the column comes in RDBMS environment, in non-RDBMS environment or NoSQL database. There are other terms used, but whenever you speak about data, it always comes in a tabular format. So even in NoSQL databases, you have to define data type for so-called either item, document and whatever. So here in DynamoDB, we have a table. We are already, whenever you discuss about DynamoDB, it's not a database. We always discuss about DynamoDB table. So what are the attributes? Attribute is a column name, and what are the data type? So in DynamoDB, data type are divided like scalar data type. What are those? So single value will be accepted here. A scalar data type can be represent exactly one value, and the scalar data type are number, string, binary, boolean and null. Document type. What is document type? A document type can represent a complex structure with nested attributes such as you would find in a JSON document. And the document type are list and map, like array, and map is like JSON format, any kind of line. Set is nothing. Set is a type of the scalar value, like set of number, set of string, set of binary. So the set can be represent multiple scalar value, and the set type are string set, number set and binary set. So overall we have divided into three parts. Now all collectively we have number, string, binary, boolean, null, list, map, string set, number set and binary set. So we'll discuss one line in a detail. So what is number? Data type. So number can be positive, negative and 0. Number can have up to 38 digit of precision, means like 9999 up to 3899 you can store in a single call attribute where the number data type has been defined. Now the string, the length of a string must be greater than 0 or is constant by maximum DynamoDB item size limit of 400 kilobyte. See, there is no specific size given for any attribute type where you are defining the string, but yes, you define your string size in such a way the whole length of the item size cannot grow more than 400 kilobyte. That is the restriction in DynamoDB table. And item size is row size. Binary type attribute can store any binary data such as compressed text, encrypted data or images. Boolean type attribute can store either true or false. Null is a value. So null represent an attribute with unknown and undefined state. List is a type of attribute that store the ordered column of ordered collections of value, and the lists are enclosed in a square bracket like array. Map is a type of attribute where unordered collection of name value pair can be stored, and map are enclosed in a curly bracket. So any JSON format data you can store it as a map. So what is JSON format? Any line which start with curly brackets and end with a curly brackets, and just simple language. String set, yes, string set can be number of strings. Number set, it will be list of numbers. Sorry, one important point, the number set can have the combination of positive, negative, okay, and with point number values. Binary set, you can have a binary set of data. So apart from that, you can go to this below link and check about the reserved words that we use for the data type or any other syntax in DynamoDB. So this is the brief introduction of DynamoDB Datatype. Now, DynamoDB throughput capacity. What is the need to discuss this? Any database has a throughput capacity. Even if you work with an RDBMS environment, the throughput capacity is what is input, what is output per second. How much data can be written per second, how much data can be read per second. That is the throughput. But what is the need to discuss here? The important point is your DynamoDB table billing will be directly proportional to the throughput capacity of your DynamoDB table. So let's see here. So there are two terms, throughput capacity and the throughput capacity type. And the type can be defined, what type of throughput capacity you want to configure. You can configure either while creating the table or later on if you have a table you can change that settings. See here, DynamoDB throughput capacity, the read-write capacity mode that control how you charged for read-write throughput and how you manage the capacity. That's the reason this topic is important to discuss. In DynamoDB, the billing will be generated with the whatever the throughput capacity. The DynamoDB throughput capacity depend upon read-write capacity mode for processing read and writes on the table. So I told you there is a capacity mode. What are those modes? There are two types of read-write capacity modes, and these are on-demand and provisioned. Apart from that, if you want to set on-demand and if you want to set provision, you can do it while creating the table or you can change it later. If you have an index you want to create on the table, it will inherit the same property, you don't have to bother about. So global secondary indexes inherit the read-write capacity mode which kept from the base table. So whatever the capacity mode has been configured on the base table, the index will take the same. Why? Because index will again create a separate segment and separate storage. Very similar to our in RDBMS environment, when you create an indexes, it creates a separate segment. Most important point. You can switch between this capacity mode once your table has been created, but there should be a gap of 24 hours. So you can switch between read-write capacity mode once every 24 hours. So it's not like that. If you have a table, you have put in capacity mode is on demand, and after 5 hours you feel that I have to put in provision mode, you can't do it. Now we'll discuss what is on demand. So Amazon DynamoDB on demand is a flexible billing option capable of serving thousands of requests per second without capacity planning. Okay, and read request unit and the write request unit. So what exactly meaning of on demand and provision? So that's the reason here there is a read request unit and a write request unit. So there is a term used in DynamoDB table. What is read request unit or what is a write request unit, or you can use another term, what is read capacity unit or what is write capacity unit. Based on this unit only your billing will be generated, and they have a chart like one read capacity unit is equal to, just an example, $1, and one write capacity unit is equal to $1. Very simple if I am putting the things in that way. So When you put your table in a DynamoDB table in on-demand mode, you cannot see the table that sorry, you have to use 5 capacity unit only, or 10 capacity unit only, or 2 capacity unit only. You cannot tell because it's on demand. So it's depend upon how much load is coming on the table. The table will increase its capacity unit and it will decrease its capacity unit. So as per your use, your charges will be calculated for the billing purpose. But what is this read capacity unit and the write capacity, read request unit and the write request unit? This is one write request unit is equal to 1 kilobyte write per second. So one write request unit will write 1 kilobyte write per second. One read request unit, if you have put a strong consistency read, then it will read 4 kilobyte. Okay, but if you are putting eventual read consistency, it will take 1 by 2 because one read request unit is equal to one strong read consistency for 4 kilobyte and 2 eventual read consistency for 4 kilobyte per second. That is default. I mean, it's a bit confusing. Am I right? Simple. One write request unit is equal to 1 kilobyte. That is clear. One read request unit is equal to one strong read consistency for 4 kilobyte. But 2 eventual read consistency for 4 kilobyte means one eventual read consistency required 1 by 2 read request unit. I think that is clear for up to 4 kilobyte of records. So now example, suppose you have discussing about a 6 kilobyte. So 6 into 1, 6 write request unit is required. Am I right? Because 1 kilobyte, so 6 will be 6 write request unit is required per second. 6 kilobyte and read request unit work with a 4 kilobyte of unit. So 4 plus 2, 2 read request unit is required for a strong consistency read, and 1 read request unit is required for eventual read consistency per second. So in you saw my previous video. I have already explained the DynamoDB in introduction of DynamoDB AWS databases. Like in the DynamoDB, the writing is costly, reading is cheaper. So suppose one read request is equal to $1 and one write request unit is also $1. So if I have to write the 6 kilobyte of record, I have to pay $6. But if I have to read the 6 kilobyte of record, I have to put the $2 for a strong read consistency, and for one, and if I am putting eventual read, then I have to pay $1. It's that much cheaper. Reading is much cheaper than writing. But this suppose I want to put whatever the load is, that I want to put only the 5 write request unit can be generated. Let it be lag. Only 6 read request unit can be generated. That is not possible. Why? Because I have put my table in on-demand mode. So when you put on-demand mode is good option. If any of the following are true, you create a new table with unknown workloads. You have unpredictable application traffic. You prefer the ease of paying only for what you use, because if you put provision 1 up to that, the billing will be generated. On demand is currently not supported for AWS data pipeline, DynamoDB import export tool, and AWS Glue. I mean, this slide is a bit confusing. Yes. So DynamoDB table is a table where you store a data, you read the data, you write the data, and it can integrate with other tools of AWS. So this data pipeline and a Glue are a tool, a service provided by AWS, and that comes under AWS Analytics. So if you are integrating your DynamoDB table with AWS data pipeline or AWS Glue, you cannot put your DynamoDB table in on-demand mode, on-demand throughput mode. You have to put it provision mode. That's a line I want to explain. Now, if you choose provision mode, while creating a table, you can define how much read capacity you need and how much write capacity you need can be created for this table. And if load is increasing, that will create a throttle to the application. That's mentioned here. If you choose provision mode, you specify the number of read-write capacity unit that you require for your application. If your application exceeds your provision throughput capacity of a table or an index, it is subject to request throttling. I want to explain a very simple terminology that we are changing. Sometimes we are saying a read request unit, a write request unit. Sometimes we are saying a read capacity unit, a write capacity unit. What does it mean? Nothing. If you are putting your table in on-demand mode, the terminology change to read request unit and write request unit. But when you are putting your table in a provision mode, then the terminology change. You say that read capacity unit and the write capacity unit. Yes. So one write capacity unit is equal to 1 kilobyte per second, and one read request unit is equal to one strong read consistency up to 4 kilobytes and two eventual read consistency up to 4 kilobyte per second. So to read a file of 6 kilobytes, same example, 6 write capacity unit required, but 4 kilobyte one, and because it will go up to 4, below 4 it will be the same. So again for the 2 kilobyte, another process will get generated. So two read consistency is required. Sorry, two read capacity unit is required if putting a strong read consistency. If you are putting eventual one read request unit is required. So read request unit capacity value doesn't change either you are putting your table in provision mode or on demand mode. That is clear. Your table things is not getting changed. Now, provision mode is a good option if any of the following are true. You have predictable application traffic. You run application, those traffic is consistent or ramp gradually. You can forecast capacity requirement to control cost. You can use auto scaling to adjust your table provision capacity automatically in response to traffic changes. Yes. Means that suppose I created a table and I put this read capacity would be 5, write capacity would be 5, but all of a sudden the load is coming. So this is a kind of situation that you want to create between your provision table and on-demand table, a kind of auto scaling, like okay, today I have a 5 read unit and write unit capacity I have defined, but sometime I need it should go 10, 20 or 50. So you can tweak like auto scaling, like if the load is getting increased on a table up to 90% and 80%, please increase the capacity unit. You will see that, I will show you. That's line 1 to see. Now the another point, if you use a AWS management console to create a table, this auto scaling will be automatically enabled if you are putting your table in a provision mode. But if you are creating a table through AWS command line, you have to put argument and option both. Then only the auto scaling will be enabled. Reserve capacity, yes, reserve capacity is something like you can buy in advance and keep it with you. With reserve capacity unit, you pay one time upfront fee and it will be very cheap, very similar to reserve instance unit in EC2. And minimum use, with the reserve capacity unit, you pay one time upfront fee and commit to a minimum use label over a period of time. By reserving your read-write capacity unit ahead of time, you realize significant cost saving compared to on-demand provision throughput setting. Yes, we have seen that in because it's very cheap if you are doing a reserve capacity unit. So it is not in on demand. Yes, because on demand is only so whenever load increase, the capacity will increase. What is transaction read write? I'm just putting this term. It's whole a new topic. There is a new you can say concept has been introduced in DynamoDB table, that is say that claim that DynamoDB table follow the acid rule. Okay. What does it acid rule? It follow the relationship. Like if you have a parent-child relationship in an RDBMS environment, similar you can apply here in a DynamoDB table. How? You can put your parent TB table, table in a parent table from RDBMS in a DynamoDB table. Same you can put child record also in a DynamoDB table. Now what you will do? What you can do is you can write a single transaction script, where first line you are showing that change the record which belong to parent table. Other update saying change the record or put a new record belong to a child record and run it. So simply, if you are not putting in some quotation, that is called read transaction read quotation, or some batch file, there is a format to put it. The parent record will be applied, even the child record is not applied, it doesn't bother. Child record applied, parent record not applied, doesn't bother. But if you write in a transaction batch mode in DynamoDB, if there is a get put item record present for the parent table, and second line also the put item record present for the child table, if any one of fail, I repeat, if any one of fail, the whole batch file will be revert back, the operation will be revert back to maintain the data integrity and the relationship between the data. That says transaction read. So when you put a transaction batch, that's a new concept. If you write your code in a transaction batch, and then you're applying, that is writing transaction record, and if you try to read through with a relationship, that is called transaction read. So the transaction read and write is different from the standard, because we have to put a batch where we have to use the some syntax transactions. So what will happen in that case? That is costlier than the standard read write, because the capacity unit value change here. In DynamoDB, a transactional read write differ from the standard one. A standard read write because it guarantees all operation content in a single transaction set failed, get succeed, or failed as a set. This is the important point. The transaction read request require 2 read requests. You need to perform 1 read of item up to 4 kilobytes. Okay, 2. It is reading is also costlier than a strong read consistency. Transaction write require 2 write requests. You need to perform 1 kilobyte. Like whatever is there in standard read write capacity, the value get double here. Very simple and layman mathematics. The value get double here. So whatever the cost coming from standard read write, the value will get double from the transactional read write. Now the peak traffic and a scaling property. What is that? DynamoDB using on-demand capacity mode automatically adopt your application traffic volume. But how it adopt? Suppose I have a table and I'm putting in on-demand mode, and it has some read write reading per second something 20,000. All of a sudden it comes as a 40,000. Will my table be able to scale it and accommodate it? Yes, it will. But I will show you through the diagram. On-demand capacity mode instantly accommodate up to double of the previous peak traffic of the table. How? Suppose you have a table, it has an item and it is a peak traffic, and 50,000 read per second is going on. All of a sudden, in the next load to handle, it is ready to have a 1 lakh read per second, because it can handle the double of peak. Yes, DynamoDB table has that much of capacity. But there is a limitation, and this is the limitation. Throttling can occur if you exceed the double your previous peak within the 30 minutes. So suppose all of a sudden my peak got increased to 1 lakhs. It should maintain 1 lakhs value up to 30 minutes or below. then only the next value or next load of 2 lakhs read per second a table can accommodate. Suppose at 1 p.m. the load got increased up to 1 lakh read per second, and 1 p.m. and 1:15 p.m. if the value get double, the application will face throttling. But after 1:30 p.m. if the value get double or 2 lakhs read per second is coming, there is no problem. But if you're putting table in on demand and you are getting a throttling in your application, you feel that the doubling is happening within the 30 minutes. So this is the scaling property and the peak traffic value on DynamoDB table when you put in on demand. Take away from the session. So before going what we have learned today, let me show you DynamoDB. So I have logged in my AWS account through my Throughput training. I'm in a services, click on DynamoDB. Oh, it's refreshing. So we'll go to the dashboard tables, create table. See this total capacity unit this is in for the OEO, leave it, create table. So you have to put table name. I have already shown in my previous video, partition key, table settings. See this, use default settings, click no. See this, read write capacity mode, provision mode, free tier iglegible up to 5, on demand if you choose, provision capacity not applicable, auto scaling not applicable. If you want encryption at rest, you can choose it. If you put provision 1, see this, read write capacity 5 is default because it's a free tier, auto scaling. If you want to create auto scaling for read capacity or write capacity, you can do this. If you want to put both, you can put target utilization, like if the table is getting utilized more than 70%, the maximum provision capacity can go to this much. You can put like 10 value. Here you can also put 20, or you can put 10. Apply same setting to global secondary index. You want to put yes or no, you can disable that. This much of asset is present, and you can click one. So it's very simple. I just show while creating the table. If you are going on this use default, so always will get use default because we show the demo, we ignore that. But here if in table setting you click, and you will get everything, capacity mode, on demand and all. And that is important because based on read request unit and write request unit, your bill will get generated in the dollar. Simple. So what we have learned today in the session: when you switch the table from provision mode to on demand mode, DynamoDB make changes of the structure of your table and partition internally. You don't have to bother about. There are two capacity mode, provision and on demand. When you use the term read write request unit in case of on demand and read write capacity unit in case of provision mode. So don't confuse with the terminology. Pricing in DynamoDB is depend upon read capacity unit and the write capacity unit and the storing data in your DynamoDB. Yes, storage plus read write capacity unit. You can set read write capacity mode when creating a table, or you can change it later on. You can switch between read write capacity mode once in 24 hours, and global secondary indexes inherit the read write capacity mode from the base table. That's all for today. What we are going to discuss in next session is DynamoDB CRUD operation using Python and Lambda, because DynamoDB is a development database and we are using Python, most popular language, and we'll use Lambda to integrate and see how we can do create, insert, update, create, read, update and delete, and then lab on it. Thank you. Let's keep learning. If you have any feedback, please send us to feedback@capro.co.in. Apart from that, if you want to learn other technology or blockchain, cloud, data science, ETL, data lake, DevOps, big data testing and cloud testing, please follow us on YouTube, Facebook, LinkedIn and Twitter. Thank you. Thanks again, and well, let's keep learning.